Okay, lesson 50. So you're asking to solve these trig equations. So notice this 2 times theta. You can't divide by 2. You've got to solve for this, and then after you get the degrees that this equals, then you can divide by 2. Also, you need to recognize this as something that has been rationalized. So you need to think of it as negative 1 over the square root of 3. This says between 0 and 360, so that means you're going to have more than one quadrant that it works in. So the way to think about this is what quadrant is tangent negative in? It's negative in this quadrant, and it's negative in this quadrant. Okay? And I want this angle, I'll put an X right here, and the tangent's got to be negative 1 over the square root of 3. But it doesn't really mean negative 1, it means negative 1 over the square root of 3. So I know that for tangent, this has got to be my 1, and this has to be my square root of 3. This one is negative in this quadrant, and that's positive, so it makes it a negative. So doing the same thing over here, for this to be negative 1 over the square root of 3, that has to be the 1, and that has to be the square root of 3. But that one's positive, and this one's negative. Then you look at this, and you say to yourself, what degree measure is this? So you have to think of the 30, 60, 90 triangle and the 45, 45, 90. So this would be a 30-degree angle right here, okay? Which means that is 2. So you want to get this measurement right here. If that's 30, that is 150. So 2 theta equals 150. You also, if this is 30 right here, I want the measurement of that angle right there. So if that's 30, this one all the way around is 330. Now I'm going to divide by 2 for both of them. Okay, now because it's been multiplied by 2 initially, but then I divided by 2, I can actually go all the way around the circle 360 degrees and then go another 150. And although then when I add 360 to 150, I get 510, I'll then have to divide it by 2, and I'm still under 360. So what you have to do is you have to add 360 to each of those. Then divide by 2 to get your answers. Now this one's getting really close to 360, so that's going to be the end of them. Okay, let's try it on this one. First thing is I need to move that to the other side. So I get the sine of 2x equals 1/2. So I have to think, when is sine positive? Well, sine is positive in this quadrant and then in this quadrant. I want the sine of this angle right here. The sine of it has to be 1 over 2, like that. Then I look at it and I say, okay, well that makes that a 30-degree angle too. So I want this one, which is 30, and I want this one, which is 150, right? Okay, here's the problem though. They want you to do it in radians. Okay, so it's okay that we did it in degrees up till now. In fact, you could even finish it and then do a conversion. It's actually easier not to do that though. It might be easier to figure it out in degrees, but right now, go ahead and change that to radians. So that 30 degrees in radians is 1/6 pi. Right? And 150 degrees in radians, you do 150 divided by 180 and then just reduce it. You get 5/6 pi. Now the reason I want to do that is because when I divide by 2, I can just multiply each side by 1/2, and that makes it really easy. So if I multiply that by 1/2, so I get these 2 answers. Now I got to do the whole thing around again. Okay, so what I'm going to do is I'm going to add 2 pi to that and then divide by 2. 2 pi because it's the same as 360. But let me show you a shortcut. If I'm adding, like up here, 360 and then dividing by 2, it's the same thing as just adding 180 to this answer here, which is what you get there. Okay? So if it's times 2, do 360, divide by 2, and just add 180 to your final answers. So here, if it's 2 pi that you're adding, and then you have to divide it by 2, you're just going to add pi. So that's, in this case, if I add pi to that, that's 12 over 12, right? And I get 13 over 12. So I got these two answers. And then if I add 12 over 12 to that, I get 17 over 12 pi. And you get those two answers. Okay? Okay, this one right here is in the form of a quadratic. So what you have to think about is you have to let the secant of theta over 2 be like your x. Okay, now if you can't see that too easily, then just go ahead and replace it. Okay, and then solve for x. Well, I think I can factor this one. If not, you can use the quadratic formula. But this is a 2 and a 1. That makes 8. That makes 1. So if this is negative and that's positive, I'll get what I need. Now what I'm going to do though now is, I'm going to have 4x plus 1 equals 0. But instead of writing the x, I'm going to write secant of theta over 2 plus 1 is equal to 0. And then I'll write x minus 2 equals 0, but put that in the place of x. Okay, then I'm going to solve these. So this is 4 times the secant of theta over 2 equals negative 1. So then I'm going to divide both sides by 4. And I'll get the secant of theta over 2 equals negative 1/4. And I'll do the same thing here. Bring that 2 over. Okay, now secant is 1 over cosine. So if secant is 1 over cosine, then that means cosine is 1 over secant. So what I mean by that is I can turn secant into cosine as long as I just flip the other side. Okay? So flip this, it becomes cosine. Flip this, and you get 1/2. Now, sine and cosine, both of them, can never be bigger than 1, and they can never be smaller than negative 1. Okay? So that means this one is not possible, so just throw it away. This is the one you're going to work with. Okay, so now I want cosine to be positive. Cosine is positive here and here. So for this angle right here, I want a cosine of 1 over 2, or 1 over 2 down here. So if that's 1 and that's 2, then this one right here must be 60 degrees. So that's 60 degrees. I got theta over 2 equals 60. And this one all the way around, which is going to be theta over 2 equals 300. Now this was not 2 theta, it's 1/2 times theta. So to solve for theta, I need to multiply both sides by 2. Now when I do that, I very quickly go over 360. So I can't use that one, and I only have one answer. So you're not going to be going around the circle and adding to this one, are you? Okay, I hope that's helpful.